Hello and welcome to episode 24 of the Game Dev Tutorials. I know it's been a little while, sorry guys. Life kind of caught up with me, but worry not, even if it's been a little while, I will produce more. Today what we want to do is we want to thread. We're going to use what C# calls tasks and to do so, and then we're going to do that to our AStar and for every other mob other than our spiderling. We're going to do some quick cleanup. There's a couple minor bugs in here that I want to get rid of. And we're causing some little twitches last video. We want to change the base pathfinding in mob to use our AStar method. We want to repeat repath every 200 milliseconds. And we want to thread the repathing. So threading is a bit different than every other kind of programming. Normally, everything executes line after line after line after line. So for instance, let's say we were threading this specific function. This would go, if we weren't threading, this specific function. This line goes, then this line goes, then this line goes, then this line goes. It's sequential. It's very simple to think about. It's very easy to plan for when you're programming. Overall, very straightforward. When we are threading, what happens is once you spin up a thread, let's say the thread spins up here. Everything within that thread is sequential. So this line goes before this line, goes before this line, goes with this line. But these are in parallel. And they're not running here, 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 here. That's not how it goes. What happens is this thread typically is going to run on one or more processors, and this thread is running on one or more processes. And just depending on what lines are running and what is more complicated will depend on the speed. So you have no control over when this ends. You can try to detect it. You can try to do things to kind of manage your parallel processing so that this doesn't try to call something, this main thread doesn't try to call something that your parallel thread is calling. That will oftentimes cause lots of errors. But you don't know necessarily when this is going to end when you start it. You can have a guess, but you don't even need to guess. You really shouldn't have any code that requires, so like let's say your memory location 1000 is something that your main thread needs. Your parallel thread, your thread, non-main thread, should not use it. And if it does, it should use it in an individual instance, and it should be very, very well error checked. Let's put it that way. Okay, so, and then also you can spin up as many threads as you want, right? So we spin up another one, and then we have this parallel thread, so on and so forth. And we can have as many as we want. Typically though, I mean, if you have more threads than you do processors, you are probably not doing yourself a whole lot of good. It can be easier to program it that way. So let's say you have, a processor, let's say an i5, and that sucker has 4 threads, or 4 processors. They're what is it called? Hyper-threaded. So it acts as 4, whereas the i7 is still 4 processors, but it acts as 8. Anyway, it won't do you a lot of efficiency good to have 10 threads, but spinning up those 10 threads may just be easier for you to deal with than trying to make sure you always have 4 or less. And it won't really hurt things. It'll slow things down slightly, actually, but it's not the end of the world. And so, I mean, if you choose to do it, that's up to you. But I figured I'd mention that. Alright, so that's my quick diagram on threading. Hopefully it made sense. If you need something clarified, just ask. And then we'll work on it. Alright. Let's see. So first thing we need to do is clean up our pathing bit here. And it's move unit is what we need to clean up. So we have some flickering happening, and that happens because our rotation can go to 0 here. So our rotation should be dealt with here. So we know that position is not equal to move to, so it's not 0 when we try to rotate it. So before the position, we actually don't know after we move it whether it's equal or not, because we're not testing for it. We could test for it and then we could do it afterwards, but for right now this works well, and that will remove the flashy bugginess that we were seeing at the end of the last tutorial. Very minor, just placing it in a different spot, little thing, but it fixes the bug. Okay, most of everything we're going to be doing is going to be here in mob. We are going to be redoing this function, but what we're going to do first is we're going to look at what we did in Spiderling, because Spiderling is similar to our goal here. This is going to be more complicated, which is why we didn't do it last time, but it will serve to be good to look at. So, alright, first things first, we wanted to change to using this, right? This pathfinding, AStar. Okay, now the difference between these two right here, I'm just gonna, I don't need building, I need, this part is my pathfinding, right? That was just finding my building. So let's take that, let's put it in, and then let's replace the building stuff. We don't need this, I'll delete it now before I forget. We don't need the stuff to find the building. Instead of the building, what we want is we want to move towards the position of the hero, right? So that's the goal right now. So let's replace the couple places where that's at. So now we're no longer pathing towards some temp building. We are now pathing towards the hero. We don't need to do rotation anymore because we do that in move unit, which is right here, which we just edited. So we don't need these at all anymore because we have move unit, which is right there. Okay, so now this here will... Ooh, we don't need this one. We need to go towards unit, right? Or towards hero. So we do that. Good deal. And then we don't need this. Okay. So what happens? It says, hey, if we have no path, right? That's what it's saying. Find a path. And if we have a path, move and check if we're hitting. Now, so what's going to happen here? And this is not what we want, but this is what's going to happen. It's going to path to a certain location, wherever the hero was. Let's say we moved. It's going to get to the place where we used to be, and then it's going to repath to where we are now. Right? So let's test it. Let's make sure that that's what it's doing. And this should be all mobs other than Spiderlings doing this. Because we don't have any other AI functions currently. As soon as this decides to run, there we go. Let's push play. Let's build ourselves a little wall of stuff. Notice that it came over there. It's going to go over there, and then it's going to come find me. So they're going to the old location where I was when they passed. So I was like right there. So they're going to start there and come up here. You see how that is? Is that better than what we had? Well, it at least avoids the towers like it's supposed to. So that's a step in the right direction. But it isn't what we really want. So let's be done with that. But we have something working. Technically, this is a working program, and the end result is that the mobs are chasing you in a really odd, roundabout way. But it is something. Okay. The next thing we want to do is we want to update this this function here to do so every so often, right? So oops. Let's say public MC timer repath timer equals new MC timer. I don't know, 200 milliseconds. That's like every, what is that? I'm sorry, my brain's not working. Every 12 frames. That's not too bad. We could handle that. And it's not going to be all units repathing every 12, each 12 on the 12th frame. The mobs are going to spawn at different times, and so they'll be spread out within the 12 frames, and so you're cutting down your pathing by 1/12. Now, you make this longer, you cut down the resources needed, but you make your pathing less accurate. So you have different options in this way. But for right now, this is going to serve our purposes. So let's deal with that. To make this work, what we're going to say is inside here, we're going to say, what's the timer's name? Repath timer equals dot. We need to test in here. So if repath timer. Sorry, not being able to remember the timer's name from 5 seconds ago was throwing me off. All right, so if repath timer's test, that's not correct either. It has to go in here because it'll never get in there if we already have a path. So, sorry guys, a little roundabout. Okay, so we come in here if there's no path, if the path is finished, or if our repath timer is testing true. And so we will repath timer dot reset to 0. Okay. This will allow it to continue to repath, and then what we need to do is we need to in the AI we need to update it. So repath timer dot update timer. Cool. So now what'll happen is our mob will not in parallel yet, but it will update its pathing. So this will look a lot better. This will look a lot better. Let's run it. Let's build our little wall of towers so we can see things going around them. Okay. This is a problem, right? We're repathing, but what's happening is it's finding the old spot, and it keeps going back to the old spot, and it's repathing too fast to fix. So what is the fix for that? We need to edit our pathing and remove the first node, because you actually don't want it to go back to the center of the first AStar node that we found, or grid location, whichever one you want to talk about. So we'll come in here, and right at the end, after we reverse the path, what we say is we say path dot if path dot count greater than 0, maybe greater than 1, yeah. Because if it only returns 1, we don't want to remove that. Now it thinks it has no path when it does, and we may actually need that spot. Let's say the original node that you're testing for is actually where you want to go. Then you want to actually have it. So okay, good. Then we'll say path dot remove at 0. So we just remove the very top node, which is the location that your unit is testing within, and we don't want to walk to the middle of that each time. All right, cool. I guess that's a little bit more cleanup. Let's see. There we go. Now they're pathing towards us. So now, if you watch this, it's continual. They're updating their paths. They are getting new information way more regularly, and it feels as though they're chasing us much better, right? It doesn't feel like they're going to our old location. It feels like they're actually chasing us. Good. That's a good step, right? Now, what's the problem with this? Well, the problem with this is now instead of just going towards us like they used to, they actually have a relatively complex behavior that they're performing by pathing. And if you had hundreds and hundreds of mobs, you're going to start to catch lag. So we want to employ the rest of our processors, right? Our main thread only runs on our first processor. It doesn't move. It doesn't matter how many processors you have a single-threaded programming running on your first processor, or whatever processor it's assigned to. So let's start to take advantage of the fact that just about every CPU these days has multiple processors and multiple threads. To do that, we are going to make sure we're threading. Let's make sure our includes have it. There we go. We need those 2 lines. If you don't have these 2 lines, we will have a problem. So make sure that you have those 2 lines. We are going to need a bool to tell whether we are currently repathing. So let's say that we have thousands of mobs on the screen and they can't all repath within the 200 milliseconds that we're giving them. Well, we actually don't want them to try to repath while they're repathing. That will cause a race condition, and that will cause problems, or could cause problems. Race conditions are famous for being extraordinarily hard to debug, and also extraordinarily painful. I guess that just goes back to debugging. Really, they're just... race conditions are horrible. Do your best not to do them. Alright, so we need a bool. And, oh, that's not the right place. It's in mob. So we need a bool for repathing. So public bool currently pathing. Sweet. So currently pathing, we're going to set it to false, because we are not currently pathing when it loads. And that, so we'll go in here. And we are going to say if currently pathing, not currently pathing, sorry. Then we're going to go in here. We're going to say currently pathing equals true. And at the end, we're going to say currently pathing equals false. And that seems real weird, I am sure, to you, because this is all currently running in parallel. So why in the blazes would you need to know between here and here whether it's true or false? Well, the answer is because it's it's not running in parallel, it's running in serial. We are going to put it in parallel, and that is going to mean that if our program comes to update the AI again and these conditions are met, but we are not done pathing, it's going to skip this, which is going to be our threaded area. Okay? You'll see just 1 second. I'm sorry I keep putting my terminology backwards. Trying to talk while working is not always the easiest thing. Alright, so the last thing that we have to do is we have to put our thread in. So, we're going to say task, load, or repath task. Most of my tasks are either pathing or loading, so bear with me there. Equals new task, and then you're going to have to open it, put 2 more parens, and do that. Okay, so that is basically saying run everything in here as part of your task. You're going to close that paren, square bracket, and the paren, and a semicolon. From there, you're going to say repath task equals dot start. STA start. Okay, so, and then I typically do one of those. That says current animation, not current pathing. Okay. So now, if we aren't pathing, we try to path. If we are pathing already, we skip it. No big deal. So this will offload our pathing tasks, our pathing functions to our other processors. Bear in mind, if you're doing this for mobile, you need to be careful with this, because the more CPUs you engage, the faster you burn through somebody's battery. But nobody likes their game to lag, so there's a fine balance. Just keep in mind, the more CPUs you engage, the more battery gets burnt. Cool. If you're just planning on doing like Steam games, then nobody really cares. They are using an extra 5 watts or whatever. It's just not a thing. Don't worry about it. But if you are doing mobile, consider it. All right, so this, I believe, should work. Provided we didn't break anything, we should now have our threaded pathing, and we really shouldn't notice any difference between the last one and this one. The only difference is that we are protecting ourselves against lag. And they are pathing nicely. Ooh, you got me. Now, again, they only path right now on that 8-axis movement. We will have to work on that. That's a smoothing out thing that we'll deal with. But everybody is pathing well. So, alright. Well, that is the end of this tutorial, guys. If you enjoyed it, please make sure you like the video. If you're not a subscriber, please subscribe. I do plan on covering more and more topics. I'm still going over a whole lot of the basics, like the threading, like this one, like we did AStar. We've gone through a lot of things, and I plan to keep doing that. I do want to get into some more gameplay elements that are a little bit more fun, as this kind of stuff is a little bit more on the dry side, and then we'll come back to the more dry stuff, because it is important. You have to be able to do this stuff. If you can't, or you don't, if you can but you don't use it, that's bad, and if you can't, that's bad. So we need to both be able to and also employ them. Guys, if you are enjoying this content, please consider Patreon. It means a lot to me, and it also will mean a lot to the channel and what I can provide for you guys. On top of that, I hope you guys are having a great day or had a great week. I'm sorry that I missed a week. I will continue to get these videos out. Please bear with me on times where I just simply, life has too much stuff going on for me that I can't get to it sometimes. Alright? I do enjoy this. I am going to continue doing it. Again, sorry, this one's a little later than the others. Have a good one, guys.